So when we were looking for sessions to do for Wednesday night meetings, Frank and I came up with the idea of doing something on 3D printing.
This is at the request of Phil.
And Phil had some. Phil requested it. Frank reminds me, and there's some other guys that were interested in it. This is one of those sessions where I'm really hoping that everybody out here doesn't know more than I do. Okay, but what I'm going to show you is what I know how to do and what I've done some of and what some of the other guys have done, and then we'll see where we can go from there. So what I want to talk about is number one, how a 3D printer works, some of the stuff you can make, finding some pre-designed stuff. You know, you don't have to build everything yourself. Sometimes somebody else has already built something, and then I'm going to show you a real basic session on how I build out a really simple work object for the satellite station. So this is what my printer looks like. All right, I have a Prusa printer, pretty similar to whatever the other printers are. You can see there's this table here, and this moves in and out. There's a print head here. Sorry, you guys on Zoom won't see my laser, but the print head can move sideways. Okay, there's a band here that moves it sideways. And then there are two knurled rods here that move it up and down. Okay, so it can basically move in 3 dimensions. And then there's two spools of filament here, one here that's black and the other one here that's gray. And the gray one is connected up there. And then there's a control knob down here. Because I've experienced runaways, like I'll show you a little later. This is a little Wise camera that's aimed down at the bed, and this is a little gooseneck lamp that's aimed out at the bed, and that will let me watch what's printing from someplace other than sitting in front of the printer, which I have to do in many cases, including the case of the example that I'm going to show you tonight. So this is how these things work. Basically, you've got the bed that moves in and out. You've got the head that moves sideways. And then, like I showed you, there's these knurled rods here that will move it up and down. And that's where you're getting your 3-dimensional movement. And this little thing injects down filament and starts building up layers of it like this. So there's basically, here's your roll, and here's these little wheels that are in the head, and that goes down and it squeezes it right through this print head here. And then it starts laying layer after layer after layer of whatever you're printing with on top of the previous layer. Obviously, there has to be a previous layer. Okay, and as the bed moves, it will decide where that stuff goes. So really, basically, that's how the printer works. I'm going to mention Printer Filaments just because I had to put it in someplace, and I am not an expert on this stuff, but there are different types of filaments you can print with. I'm used to printing with stuff called PLA, which is really general purpose stuff. It's pretty easy to work with, but I've been told by Frank and John Zaruba and the guys that are really expert at this, this is not heat resistant, not strong. It works it warps in sunlight, and you really can't use it for anything that needs to be strong or outdoor. Oh, John says it smells like cotton candy. So I've never tried to get high on my 3D printer, but maybe that'll work. There's stuff called PETG, which I have worked with. It's a little tougher and harder to print with. There's stuff that I called TPE, which I'd never seen. Got this off of the web, that is apparently a little bit more pliable. I guess it's kind of like the silicon glue and stuff like that. Carl's nodding his head, so maybe I'm right about that. And then there's ABS, which is similar to toy plastic. It's a lot stronger. The problem with that, at least for me, is that the fumes are toxic. And I've got mine in an open room, so I can't do that if I want to remain on the surface for a little bit. Mark. I have not, but others have said yes. The question was, have I had trouble with PLA going bad? And the answer seems to be yes. Okay, but you can dry it out. Okay. All right. So what can you make with it? I've got a lot of examples of stuff here just because people say, well, what can you do with one of these things? So I've done some of these, and some of these are pictures that other people have given me. Some are a little specious, so you might have to be, on your toes to figure out whether they really are 3D printed or not. So this is a power pole mount. You can see there's a bunch of little power pole connectors in there. I needed a way to wire them together. And so I found this model online that just let me put a bunch of power poles together and run a wire through them. And it held them all together. It did exactly what I needed. This is a mount for the satellite station relays. We needed to mount the relays on the wall, and there's no real good way to do it. So you can see basically they hang from the mount, and we screwed it onto the wall, and I designed that little thing, and it works great. This is similar. This is a diplexer for the satellite station, and they're made to sit on a desk, except we didn't want it sitting on the desk. We wanted it hanging on the wall. And so it's just a little pocket that the thing sits in, and I designed it so that the indentations right here and right here lined up with the diplexer, and it just sits there and hangs on the wall, and that holds the diplexer up. This is a housing for the weather station. I think John made this, did you not? John Zaruba printed this. Okay, and that's outside the clubhouse. It's probably made out of ABS, I guess. John's nodding, so it is. And that covers up the temperature sensor for the weather station, but lets it measure what the temperature is. This is a case for the satellite antenna switch. Frank did this, and I wish I could show you all the stuff that's inside, because there's a lot of 3D printed pieces inside this thing. But basically, it's you can see the buttons to control the relays and the LCD panel on it. The interesting thing about this is that this was hanging on the wall in the satellite station, but in the new design of the satellite station, we don't want anything hanging on the wall. So all we need to do is take that and redesign the case, make it so it sits on a desktop, and all the guts of what are inside, which is an Arduino and relays and some stuff like that, they all stay the same. We just redesign a case, and you got a completely different product for a completely different situation. Okay, another advantage of the 3D printing. This is a box for the Othernet receiver. In there is just a circuit board. I think John Zaruba printed this one also. Okay, just a nice case that allowed us to mount it on the wall. This is a set of Downdraft SU carburetors for a 1963 Ferrari 250P. Mike K2 MRP says that he printed these things, but I'm kind of doubtful of that. Then this is an enclosure for the clubhouse temperature sensor. We have temperature sensors in each of the rooms of the clubhouse, so we can monitor what the temperature is. Inside this thing is a Raspberry Pi Zero. Mounted on the top of it is a BMT 280 sensor, and we just needed something to keep them safe and contained. So I just printed a little box that contained it, and put some holes in the top so that the temperature sensor could get touch the air, and it works really well. This is that thing is an oxygen analyzer for scuba tank. If any of you guys are divers, you'll know what that is. And I wanted to be able to put it inside this little Pelican box, and I didn't want it to rattle around. So I just designed a 3D printed fixture that's the size of the Pelican box. So there's the box. And I just, drew basically two oblong things and connected them together and printed up, and it fits inside the case and keeps the oxygen sensor from banging around. This is a piece of work. This is the As-L Rotator for the satellite station, and Frank made this, and John also made one. This is a design from the Satnogs people, but it's all printed individually. And this is what we used on field day for the satellite station. It works beautifully. Oh, and Frank brought it over. It's brought it over. So take a look at some of that stuff. I see the temperature sensor cover there too. So this is a thing of beauty, and it shows you what you can do with 3D printing. Okay. This is the 3000 pipe Wanamaker pipe organ in Philadelphia. Frank said that he printed this. I think it took most of March in 2018 to print that stuff up, but it works really well, and it sounds really great. If you've ever heard the Wanamaker organ in Philadelphia, you probably didn't know that part of it was 3D printed in Frank's shop. This is a rack for the Skunkworks Pi and SDR project that was in the clubhouse until we had to take it down for the VHF room. Each of these things is a pull-out. This is a pull tab, and this whole thing slides out. So this is basically rack-mounted Raspberry Pi, and this is a shelf here for the the SDR radio. We found the plan for this online, and then Frank modified it to work for this purpose. And then I took it one step further. In this case, this is a Pi 4 where I had I wanted to add a USB drive on here, and I wanted to mount it as part of the Raspberry Pi. So you got your Pi here, and I just designed this little rectangle with holes for the tie wraps, and then holes that match the holes in the Pi, and bolted it on. And that means that we can connect an SDR in here. We can connect a memory module and only use one slot rather than two slots like we did before. Again, it's really simple, but it's just a piece that needed to be done. And I designed it once, and I printed about 8 of them because we have about 8 of them, and that's what we needed. This is a box for a satellite controller. This is an Arduino Mega with a Grove hat on it, and there's an ADC in here to read the potentiometer in the rotator, and there's a bunch of relays underneath it, and the LCD panel here. And we basically designed this thing with the bottom and the sides and the hole here, and mounts for the Arduino. So it basically is a custom designed case for a custom designed piece of equipment. And then finally, this is a sample that came. This design came with my printer. So all I did was press a button to print it. And if you look at the intricacy of that thing, it's unbelievable. It took 13 hours to print, but it's just incredibly detailed, and it shows you what you could do with a 3D printer. So there's some examples of what you can do with this stuff. You know, we've got a lot of 3D printed stuff down at the Clubhouse. So if you want to print something, you don't have to start from scratch. In a lot of cases, you can just go out there and Google stuff, and you'll find pre-designed designs for a lot of stuff. So here I just went and Googled amateur radio 3D print, and you can see, you know, antenna mounts, another antenna mount, HT holder, and a microphone holder, and some kind of a rack, and there's a center insulator, and all sorts of stuff. And if you go look at one of them, you'll see, for example, this is a antenna feed point. So this is the page you would go to if you clicked on that, and it shows you a blow up of it, and it shows you down here. It'll tell you that there's an STL file that you can download. I'll show you what an STL file is in a minute. And you basically can download this thing and print it. So if that's exactly what you want, you don't have to do any design work at all. Okay, you just grab the thing, bring it down, print it, and you've got it. This is another example. This is a mount for 5 gigahertz helical. So you would take this thing and you'd wind the wire around it. Okay, again, it's already designed. All you got to do is bring it down. Here I went on this website, and what I typed in up there that you can't see is power pole. What do you got for power poles? And it's got all of these different things just for power poles. So if you're looking to mount a power pole someplace, this is where you could find the designs for it. And in fact, I found this one. I think if you buy these things, this is a chassis mount for power poles. I think this thing goes for like 25 bucks, you know, and you can print it for 50 cents. So, you know, sometimes it's worth actually going out there and looking for it. The filament for these things is really, really cheap. Almost nothing costs more than $1. Okay, so you can afford to make mistakes, which is good for if you're somebody like me and you make a lot of them. So that's what you can do if you can find something that's already designed. What happens if you need to make something yourself? Okay. So here's an example of one of the things that we made. This is a mount for a software-defined radio for an SDR play that we actually use down at the Clubhouse. So basically what we wanted to do is take that thing and screw it onto the bottom of the satellite table so it'd be out of the way, but we could get to it if we needed it. So it's just a simple trough. It's got 5 elements to it. You can see I made a mistake in the design here where I joined 2 edges together that don't meet. And I pointed out the 5 rectangles. If you look at it end on, you can see there's 5 rectangles here. One here, one there, one there, one there, and one there. Keep that in mind because that's how you start building the thing. All right, we're basically starting from those 5 rectangles. So what do you got to do when you want to do this? Well, you got to start measuring. So I have this digital caliper that I used, and that's what the SDR play looks like. And you got to measure the depth of it, and you had to measure the height of it. And I had to remember to include the feet, otherwise the thing will be a little bit too small, and I'll have to go start all over again. And then measure the width of it. So you need to know what those dimensions are, obviously. In this case, it didn't matter too much because we were going to have a little bit of slop anyway, so we could slide it into that easily. But some of the stuff you got to be dead on, which is why you really need the caliper like that. And then this is a video of actually starting the design. So what you'll see happening here is the first thing you do is, this is a three-dimensional design. You can kind of see the three-dimensional picture up here. I'll pick which of the three axes I want to build this thing on. I want to build it on the bottom, so I'll click on that. And then if you remember those rectangles, I'm going to draw each one of those rectangles. So I'm going to go up here, and I'm going to grab a tool here that draws a rectangle, and I'm going to drag it down, and I'm going to drop it onto the workplace here. And you don't have to size the rectangle perfectly, because the dimensions of the rectangle will show up as you're trying to draw it. So what I'm doing is I'm just kind of drawing a rectangle, then I can tab to the length and type in the length in millimeters, and then tab to the height and type in the height in millimeters, and it'll automatically size the thing for me. So I don't have to be exact the way I draw it. I just kind of have to get it on there. And there was something else I was going to tell you about that, but I can't think of what that is. John. Right. No, for those of you on Zoom, what John said is working in millimeters is a heck of a lot easier than working in inches, which is what I've always done. So the thing I wanted to mention is each of these is one of those little rectangles. So the length of it is going to be dependent on the size of whether it's the top or the bottom of the SDR case. The width is always going to be 2 millimeters, because that's how thick I want the plastic to be. All right, so just that's the part that I want to remember. So here we go. Oh, this is Fusion 360. I'll tell you about it in a second. Okay, so here we're drawing the first rectangle, and I'm typing it in the dimension, and I'm typing in that dimension. And then I'm going to go grab the next rectangle. There's probably a better way to do this, but this is the way I did it. Grab that, and I think I did the dimensions backwards on this the first time. Yep, I did it backwards. Then I'm going to go grab the third one. If you hear anything coming out of my computer, I did this while the 3D printer was printing, so the noise in the background is 3D printer noise. There's that rectangle. It's the Prusa Original Mark III, I think, or something like that. So that's actually the mouse motions you would go through to put the first 3 rectangles down, and then the other 2 you would put on the top. I didn't do that because I was afraid I was going to screw them up, and then I'd have to start all over again in the video. So that's that part of it. And then when you get done, that's what the whole design would look like in 2 dimensions. All right. And it's got all the measurements on there. It'll automatically measure them, but I also measure them myself. And that's the 2-dimensional design of it. So how do you get 3 dimensions out of it? You literally tell the thing to take the 2-dimensional object and pull it out. And that creates 2 dimensions out of 3 dimensions. So basically, the 2-dimensional part of it is down here. And if you could read this, I'm sorry you can't. It basically says pull. You see this little arrow here? You select all of these pieces and you say pull, and it'll say how high. And right in here, I set 100 millimeters. So it's basically creating that 3-dimensional object out of that 2-dimensional design. All right. And that's how that part works. Okay. So that's that piece. I need the holes because I'm going to screw that thing into the bottom of the table. So what I did there is I went back to each of these surfaces, and, you know, up in the top where I'd grabbed that square, I grabbed a circle and I dragged 4 of them down here. I don't have to place them carefully because one of the other things I can do is I can tell it where to place an object relative to another object. So in each of these cases, I said, I want this 15 millimeters from the edge. I want this 15 millimeters from this edge. I wanted 15 millimeters from this edge, 15 millimeters from this edge, so on and so on. So I didn't have to drop them in the right place. I could drop them anywhere. And then I just said, make it 15 millimeters away. And that's how I got it to be symmetric. Because if I had to do it by eye, there's no way that would come out anywhere close to that. Okay. And then I take those circles and I pull them through. Okay. If you push, you're creating material. If I pull it, it takes it away. So I basically said, take each of those circles and pull it to the opposite side. And what I could have done is I said, I want you to take the circle on one side of the edge and pull it 2 millimeters to the other side of the edge. But there's another option where I can say, take it from one side of the edge and pull it to the other side of the edge, wherever the other side of that edge happens to be. And that's what I did. So basically I click on one side, I say through, and it'll say to what? And I literally turn that object around and I clicked on the other side. And what that does is these are 2 millimeters thick. If I made it 3 millimeters thick, then the hole would be 3 millimeters. Whereas if I said, just make the hole 2 millimeters, it'd still be 2 millimeters. It'll be 1 millimeter short. So you can do stuff like that, which is really, really cool. Then I added the fillets, which are kind of the little rounded edges on. I didn't know what a fillet was, so I did 3D printing. There's a function in here that basically allowed me to select the top and then put a 2 millimeter fillet on it. And that gave me an edge like this edge here. Okay, which makes a nice rounded edge. Okay, so you've got stuff like that. And that's probably where I stopped because that's all I really needed. And it's all I really know how to do. So the next thing that I would do is I would tell it to go 3D print that, and I'll show you that step in a minute. But I kind of took a step in the meantime in that I had seen in Windows that there's a program called 3D Paint and a program called 3D Print. And I wondered whether that had anything to do with this. So the file that you create in a 3D printer designer is an STL file. It's a 3D image. And I said, I wonder if I just try and open this thing in the 3D Paint program in Windows, I wonder if it does anything. Well, son of a gun, it did. It opens it like that, okay? And I can rotate it around in that program. So I've got a little video. Tony, I keep saying it in front of you. I'm sorry. I actually fooled around with it, and I'll show you what happens. Here, I just grab the mouse. And in the 3D print program in Windows, you can do that, which is really pretty cool. You're manipulating a 3D object in one of the Windows programs. I probably could have painted something on it if I'd wanted to, although the 3D printer doesn't know anything about paint. It doesn't know any painting. All it knows how to do is print. But I thought that was kind of an interesting observation for me to see how this 3D printing stuff, goes into Windows. So the next thing you got to do is you got to print it. And there's a function on File, 3D Print, and you select the object that you want, and it dumps it into a program called a slicer. So this thing you can see, this is the default. So it laid the thing on its back on the bed of the slicer. This is where you would bring in an STL file. If you downloaded something, if you didn't design it, you bring it into this program here. Okay, you haven't designed it, you've just downloaded it off the internet. Now, you can't print this thing this way. Why can't you print it this way? Well, you see the little flanges hanging out here. What's underneath them? Air. Can you hang a 3D line on that? No. So you can't print it this way. Now, there is a way. There's a function in the slicer called supports where it would actually put plastic under there and would allow you to do that, but it's going to waste a whole bunch of plastic, and you're going to have to take it out, and it's going to take a lot longer. So what I did is I just rotated it, and I rotated it 90 degrees, and I stood it up on the ends, and now it's got plastic underneath all of the pieces. So that will print okay. The problem you've got with that is that you don't have a lot of surface connected to the bed. Okay, all you've got is those little edges that are connected to the bed of the printer. And as the head moves back and forth, if that comes unadhesed to the bed, the thing's going to start flopping around and you're done. Okay, and in fact, in the example I'm going to show you, that's exactly what happened. So you'll get to see that happen. Okay, and the right way to do that would have been to put a little bit more surface down here. Maybe I put a back on it or a half a back on it or something like that. So I'm laying down more surface so it can stick to the bed better, and it's less likely to get knocked off when the head is going back and forth like that. Okay. So this is a time lapse of probably an hour's worth of printing. You know, I set this stuff off and I went and started watching reruns of Yellowstone for a while. And because I have that little Wise camera hanging over my 3D printer, I was able to take my phone every 15 minutes or so and check and see how the printing was going. And you'll see it's a good thing that I did that. So here's what happens. This is why we did not bring a 3D printer to the clubhouse so you could watch this print. This is about an hour. You know, I mean, Beth was only getting into her second fight, you know, in Yellowstone when this thing started going awry. There you go. All right, and you see, I caught it after a couple of minutes, so that was it. So that's basically the intro. I'll just show you a couple of other things that I had a devil of a time with. Getting the bed level is a pain in the neck in these things. This is a print that it gives you. It's basically a standard print that you can use to print out what it should look like. Each of these things should be nice and flat and even, and they weren't. And I'm sitting there for, you know, probably a week with feeler gauges between the bed and the head, trying to adjust things. Even though it self-adjusts, it doesn't self-adjust all that well. And finally I got to that, which is exactly what it's supposed to look like. And that let me print that castle that I showed you on about the 20th slide that was really, really detailed. And that's how it works. So on Saturday, we're not going to show you 3D printer because it would be, again, watching, you know, paint dry. But I'm going to go through Fusion 360. I'll bring over my computer and actually show you how you design some of this stuff up to the limited amount that I actually know how to do. And then Frank's going to show you SketchUp. Now, Frank did the designs for the VHF room in SketchUp, and they're really nice and detailed and powerful. And so that's really interesting. If you're doing large scale projects, apparently that's the program to work with. And then Carl, who works with AutoCAD for a living, is going to show you what real professionals can do with one of these programs. So if you come out on Saturday morning, we're going to start at 9 like we usually do, and we'll have some interesting stuff to look at. Also, remember the 10-meter contest is on Saturday. The HF room will be open, and so there can be a lot to do over at the clubhouse on Saturday. Any questions or comments?
Yeah, okay, I got a question.
Oh, yeah. Go ahead.
Oh, me?
Yeah, Charlie.
Okay. What is the height restrictions on that?
My printer is 2.5, 3 feet high with the filament rolls on it, something like that. Or are you talking about how big is a printer, or how big can you make something?
No, how big of a object can you print? How tall?
Oh, probably about a foot high, probably a foot square, a foot cubed, I think.
Nice.
So if you wanted to make something that was bigger than that, you'd have to make it in pieces and put it together.
Oh, that would be all right, because I was going to try to make a coil, but it said it needed to be 1/8 inch on center, and I couldn't wind that by myself.
Yeah, you could certainly do something. Well, an eighth of an inch is pretty small. So, any other questions? Yeah, Tony. Frank, you want to answer? I don't think so. Frank's answer was depending on the plastic, it's easy or hard. Carl?
What's your weather, the material that you print with?
Hang on just a second. We have a question in the room. Go ahead, Carl.
Temperature restrictions.
I'm sorry. Okay. Whoever's on Zoom, go ahead with your question.
The material for outdoor use, what would be your extreme temperature range for and that UV resistance?
John or Frank, you want to answer that?
There's probably no less than 20 to 30 on the market, varying friendliness to printing.
So there are several different options for printing. One of them, Frank says, would go up to about 200 degrees.
Okay, that's
Okay.
cool.
Carl. It doesn't stick that hard. Prussia actually gave me a little paint scraper thing that I can use to get under there. No, it doesn't stick that much. It's usually the other way around, and you'll see what I just got.
Did you have to dial in the extruder and the bed temperature?
Yes, I have to tell it what stuff I'm printing with, and it knows then the temperature.
Okay, so you're using the standard, like the standard temperatures for PLA?
Yes.
Okay.
Yeah. John, go ahead. Okay, for Zoom people, just to summarize that, John's printer has more temperature capability than mine does, and you can change the temperature of the bed to make it stick when you need to, and then release it when you need to. Sheldon, you had a question? John or Frank? A question is, if you printed multiple items and wanted to glue them together, what kind of glue? Can you glue them?
Other plastics like PLA do not respond to any solvents that you want to screw around with. So you're left with things like TA glues or epoxy.
So for you on Zoom, it depends on the plastic. Some of the stuff you can glue and some of the stuff you can't. It might have, but then I'd have to glue it fairly exactly. I think the right answer would have been to put a lip on the bottom of it, so that there would be, a couple of square inches on the bed. And then Frank says a slicer will do that if I knew how to do it, but I don't. So, anybody else?
Does anybody have any experience with printing on glass?
John does. Let me give him the mic.
Yeah, what do you want to know about printing on glass?
Well, as far as do you feel that it's more successful or less successful? Like I have glass on mine, and I've learned that I had to increase the bed temperature just so the heat could propagate through the glass. So I
Okay.
didn't know if anybody had any tips or anything.
Well, like my printer has a glass bed on it. I haven't. I have to kick the temperatures up a little bit, but it's not that big a deal. But the glass is really good, especially if you're printing a flexible material like TPU. The glass is really good because you get absolutely flat edges with no artifact. Where with some of the other things like PE, like a PEI bed or a steel bed, you can have some waviness and some, where the plastic conforms to the bed. So if you want like absolute flat edges, it's pretty hard to beat glass.
Okay, so do you use glue to get it to stick, or do you just rely solely on the heat?
It depends on what I'm printing with. TPU will stick pretty well to the glass by itself. If you're printing like ABS, actually Elmer's or Uhu glue stick works pretty well. It gives you just enough stick to keep the part in place, but after everything cools off, it's pretty easy to pop off.
Okay, thanks.
Thanks a lot, everybody. We'll see you in January.